In this episode of Cloud Performance Atlas, I help some IoT visionaries come to terms with load balancer performance. Will their bet on the future of technology pay off? Stay tuned to find out. IoT Roulette is a company which offers a scalable way for IoT devices to connect with cloud backends through a common and simple SDK and transport layer. A few weeks ago, I met with their CEO to talk about the biggest thing on her mind. What's the performance overhead of using GCP's load balancer? As you can imagine, scale is really important to IoT Roulette. With an estimated 50 billion IoT devices in the world by 2020, scaling your services to handle the sudden load of 1 million new devices is an important feature. So, fast-performing load balancers are crucial to get this right. But before we start talking about the balancers, we need to see how things perform directly. To get a baseline performance, we set up an instance in US Central and kicked off a bunch of curl commands from a machine in Europe. Now, if you do this test yourself, you'll notice that the curl performance can end up being double what the ping time is, simply due to the overhead of TCP handshakes involved and the transfer of the fetched data. Now, Google Cloud Platform provides 2 primary load balancers, so we need to understand the difference and profile each one individually. The first is a TCP UDP load balancer, which acts much like you'd expect. A request comes in from the client to the load balancer and is forwarded along to the backend directly. The HTTP load balancer, on the other hand, has some serious magic going on. It proxies traffic through Google front-end servers first, which stops the session on the public internet and continues on using Google's private network. So, depending on which balancer you're using, we should expect different set of performance characteristics. To test this, we set up instance groups for each balancer in the US Central region and had a load generator in Europe fetch from them using the same curl commands as before. The results show some interesting characteristics. First, the TCP balancer shows very similar results to the direct access version. This is somewhat expected. In this case, traffic moves from the user to the load balancers, which are in the region where the VMs are located. As such, performance is a factor of the distance from the requester to the closest entry in the target region, just like directly accessing the VM. The HTTP balancer, on the other hand, did something I really wasn't expecting. According to this test, it appears to outperform both the direct connection and the TCP balancer. This is odd, since the HTTP load balancer effectively adds another hop to each fetch. Instead of going from the client to the balancer to the backend, it has the intermediate step of hitting the front-end boxes first. Now, at first glance, this seems confusing about why adding an extra hop would improve performance. But once we look under the hood, we can quickly see why this works. See, when a request hits the HTTP balancer, the TCP session stops there. The GFEs then move the request onto the private network, and all further interactions happen between the GFE and your specific backend. Now, here's the important part. After a GFE connects to a backend to handle the request, it keeps that connection open. This means that future requests from this GFE to this specific backend will not need the overhead of creating a connection, and instead can actually just go to sending data ASAP. The result of this setup means that the first query that causes the GFE to open a connection to the backend will see slightly higher response times. Those are the spikes in the front of the graph. However, subsequent packets routed to the same backend will see a lower minimum latency. So for IoT Roulette, this is fantastic. The more IoT devices they get in a region, the better their HTTP load balancers will perform. Not a bad bet to make. If you'd like more details on this problem, check out the full article linked in the description below, and make sure to subscribe to our Google Cloud YouTube channel to get alerts when new performance videos comes out. Because don't forget, when it comes to performance, every millisecond counts.